Congratulations on your purchase of a new Millermatic MIG welding power source. This video will guide you in the setup and operation of your new power source. First, introducing your system components, then reviewing setup procedures, followed by a section on MIG welding principles, procedures, and techniques, and wrapping up with some troubleshooting hints. The Millermatic line of all-in-one MIG welding power sources can be divided into small and large units. Smaller Millermatic units come with a Miller MIG gun and cable assembly, a work cable and clamp, a gas regulator and gas hose, extra contact tips, quick change drive rolls, and a sample spool of solid wire. Optional accessories include a spool gun and spool gun adapter, and 2 types of running gear cylinder racks. Larger Millermatic units come with a work cable and clamp, a gas regulator flow gauge with hose, reversible dual groove drive rolls, and extra contact tips. Most larger Millermatics also include a MIG gun, and some include a spool gun as well. All larger Millermatics come with factory-installed running gear cylinder racks. Options include spool guns for those units not already equipped with one, spool gun extension kits, dual cylinder racks, and a protective cover. All Millermatics are equipped with a power cord. 115-volt Millermatics come equipped with standard 15-amp plugs, and single-phase 200-230-volt units are equipped with 50-amp plugs. Units without plugs require wiring as specified by a qualified electrician. All Millermatics feature faceplate controls for voltage and wire feed speed. The setting for the wire feed speed control ranges from 0 to 100% on some models, while on other models the control is set for the inches per minute desired. The voltage control may be tapped with a number of settings, or offer infinite adjustment. A parameter chart on the inside cover provides starting settings for common wire types based on type and thickness of metal to be welded and type of gas to be used. Every Millermatic features a rugged outer case and a factory-installed gas solenoid valve. Certain larger units feature dual gas solenoids and come with a second gas regulator flow gauge and hose for connecting a spool gun to a separate gas cylinder. All Millermatics feature a self-contained wire feeder with a cast aluminum drive system and quick-change drive rolls. Smaller systems can accommodate wire spools 4 to 8 inches in diameter, larger units up to 12 inches in diameter. Refer to your owner's manual for instructions to convert the shaft in preparation for mounting a 4-inch spool. Before you continue setting up your new Millermatic hardware, make sure that you have your welding safety equipment handy. Safety glasses, leather gloves, and a welder's helmet with at least a shade 10 lens. Failure to protect your eyes from exposure to the welding arc can cause serious permanent damage. Miller Electric suggests that you review the safety section of the owner's manual that came with your Millermatic before proceeding. Understanding the risks and taking proper steps to avoid danger is vital to your safety and the safety of those around you. Your Millermatic must be set up to convert the external electrical power provided by the electrical company into welding power. Smaller 115 and 230-volt units are shipped ready for use, but you may need to change the primary input links on larger multiple voltage and 3-phase units to match your incoming power. The voltage links on multiple voltage, single-phase units are located in the wire drive compartment. After unplugging the unit, remove the securing screw, flip up the plexiglass cover, and change the position of the jumper to modify the input configuration voltage. Complete instructions are provided in the owner's manual, and a quick reference is provided on the sticker inside the cover. More detailed electrical information can be found in the electrical service guide of your owner's manual. For three-phase units, please consult the instructions in your owner's manual on modifying the primary voltage links. Also review the information in the electrical service guide in your manual for more information on required breaker sizes. In preparation for welding, the system components need to be installed. For your safety, examine each cable and make sure each connection is secure every time you use the equipment. To install the MIG gun on Millermatics, plug the cable into the gun receptacle and tighten the retaining screw. Check to see that the distance from the end of the liner to the drive rolls is as close as possible without touching. You may need to trim off the end of the liner if it touches the drive roll. Insert the trigger plug into the trigger receptacle and tighten. Feed the work cable through the opening. The power output studs for all Millermatics are easily accessible in the wire drive compartment for changing polarity to match the type of wire used. Most MIG welding is performed using DCEP, or reverse polarity. In both small and large Millermatics, electrode positive, or DCEP, means the drive cable is attached to the positive stud, and the work cable and clamp to the negative stud. However, certain types of wire, such as self-shielded flux core, require DCEN, or straight polarity. Switching the cable positions so that the drive cable is attached to the negative stud and the work cable and clamp to the positive stud supplies straight polarity, or DCEN. You can also refer to the parameter chart for polarity information. For this demonstration, we're connecting to the negative stud for solid wire welding. To install wire on either large or small Millermatics, place the spool on the shaft, making sure that the pin on the machine fits into the hole on the spool, and replace the retaining ring. All Millermatics come equipped with dual groove drive rolls that can accommodate two different wire diameters by reversing how the drive rolls are installed. Smaller Millermatics have a single gear-driven drive roll and a second idler drive roll. The drive roll groove size must be matched to the diameter of the wire being used. On smaller units, the standard drive roll can accommodate 030 or 035 wire on one side and 023 on the other. Changing is simple. Push in the drive roll, turn it a quarter turn, and remove it. Orient the drive roll so that the stamped wire size facing out matches the wire size to be used. Place it back on the shaft, push in, and turn 1/4 turn until it pops back into its locked position. In larger Millermatics, both drive rolls are gear-driven to accommodate heavier usage and larger wire sizes. The standard dual-groove drive rolls for these machines will accommodate either 030 and 035 wire or 035 and 045 wire. To change from one size wire to another, turn the locking knob that holds the drive roll in place until the raised fins line up with the grooves, and slide the drive roll off. Orient the drive roll so that the stamped wire size facing out matches the wire size to be used. Slide it back on the shaft and rotate the locking knob until it locks into place. Be sure that both drive rolls are set for matching wire size. Now you can thread the wire through the system. Being careful not to allow the wire to unspool, unwind a few inches of wire and trim off the end so that you have a straight piece. Feed the end into the inlet guide, across the drive roll, and into the liner. On larger units, the wire should line up directly over the groove in the drive roll between the inlet wire guide and the MIG gun. If this alignment is off, you may need to turn the Phillips head screw to move the bottom drive roll in or out to line it up with the wire. No adjustment is necessary on smaller units. Close the pressure arm and raise the tension knob until it snaps into position. Remove the contact tip from the MIG gun if it's still in place to prevent jamming when the wire is initially fed through the gun. Plug the Millermatic into wall power. Turn the wire feed speed knob about halfway up and pull the trigger. Observe the drive rolls and increase the tension if you see slipping. Continue pulling the trigger until wire extends beyond the end of the gun and trim it off. Install a contact tip on the gun appropriate for the wire size you're using. Tighten it securely and reinstall the nozzle. Check the drive roll tension again by activating the trigger while holding the gun close to a non-metallic hard surface. Increase the tension until the drive rolls do not slip and the wire curves back up. Next, prepare your shielding gas. Crack open the valve on the gas cylinder slightly to blow out any contaminants before installing the regulator. Screw the regulator to the gas cylinder and tighten, making sure to keep it vertical. Attach the hose to the regulator and to the gas connector on the back of the machine and tighten securely. Open the cylinder valve slowly at first, then all the way. Now pull the gun trigger and adjust the flow rate to 20 to 30 CFH, or cubic feet per hour. Welding requires that a flow of electrical current be established between the workpiece and the power source. Securely attach the work clamp directly to the work or the metal work table to complete the welding circuit. This will allow current to flow when the trigger is pulled. Every Millermatic features a welding parameter chart inside the wire drive compartment door to help you get off to a good start. The type and thickness of metal to be welded will drive the selection of wire type and size, shielding gas, the voltage and wire feed speed settings, and polarity. Base metal types shown are steel and stainless steel, as well as aluminum on most charts. For this demonstration, we'll be welding 1/8" steel. The next column indicates the type of wire recommended for the metal being welded. Wire types include solid steel, flux core, and stainless steel, as well as aluminum on most charts. Wire type should be selected to match the base metal to be welded. Since we'll be welding steel, we'll select a solid steel wire. Suggested shielding gases is the next column. 4 gases are typically used for the MIG process. Either 100% CO2 or C25, which is 75% argon and 25% CO2, is used to weld mild steel. Trimix, which is 90% helium, 7.5% argon, and 2.5% CO2, is used for welding stainless steel. 100% argon is used for aluminum welding. Shielding gas is not required when using self-shielding flux core wires, though not all flux core wires are self-shielding. Miller Electric suggests that you consult with your local distributor for recommendations regarding shielding gas for your particular application. For this demonstration, we'll be using 75% argon and 25% CO2. Wire diameters presented on the parameter chart will vary among small and large Millermatics. This particular chart shows 023, 030, and 035. Your welding distributor can help you determine the proper wire size for your welding job. For our demonstration, we'll be using 030 wire. To determine your machine settings, now that you've selected your wire and gas types, read across the chart to the metal thickness to be welded. We'll be working with 1/8" steel, so reading down the column, the recommended voltage setting for this machine is tap 3 and a wire feed speed of 50%. The parameter chart readings for the same welding job using the same wire and gas on a machine with infinite controls shows a voltage setting of 17 and a wire feed speed of 305 inches per minute. In MIG welding, an electrical arc is created between a continuous consumable wire and the workpiece. The wire serves as the electrode in the weld circuit and provides the filler metal. A shielding gas protects the electrode and weld pool from contamination. For good weld results, make sure the workpiece is clean and free of contaminants, such as rust, paint, and oil, so wire brush, grind, or sand the surface before you begin welding. At this point, we're ready to weld, having completed this checklist. We inspected cables and connected them for the desired polarity, installed and threaded the appropriate welding wire through the MIG gun, and reinstalled the contact tip and nozzle, selected the shielding gas, and established the desired flow rate of 20 to 30 cubic feet per hour. Attach the work cable to the workpiece or work table to establish a welding circuit. Set the voltage and wire feed speed using the parameter chart or established procedures, and clean the workpiece. The next step is to put on welding gloves and helmet, place the gun into position, and begin. How you hold the gun will differ depending on the thickness of the metal and the type of weld you're doing. For thinner metals, a 10 to 15 degree push travel angle provides the best results. For thicker metals, a 10 to 15 degree pull travel angle provides more penetration. Your work angle will be determined by the weld joint type. The most common weld joints are the butt joint, the T, the lap, the edge, and the corner joint. Hold the gun so you have a 90-degree angle to each side for butt joints, edge joints, and corner joints. Hold your gun at 45 degrees to weld T-joints and lap joints. Remember, your final gun position is determined by the combination of proper travel angle and work angle. Maintain about 3/8 to half an inch distance between the contact tube and the weld surface. This is referred to as stick-out. Start by making tack welds to secure your pieces. Pull the trigger for about 2 seconds while making a slight rocking motion from piece to piece. Repeat at about every 3 inches. Watch your weld puddle and move the gun so the welding wire stays at its leading edge. This is called the travel speed and will play a part in determining the quality of your welds. Producing a good weld requires the correct combination of voltage, wire feed speed, travel speed, and work and travel angles. Following the parameter chart will get you off to a good start, but you may have to tweak your settings or travel speed to achieve the best results. Producing consistently good welds takes practice. Welding aluminum requires some special equipment and procedures. Aluminum is a very soft metal, so pushing aluminum wire through a MIG gun is difficult. Instead, a spool gun is recommended, where the wire travels a very short distance. A push-pull wire feeder and gun can also be used. To hook up a spool gun on a larger Millermatic, connect the trigger to the trigger receptacle. Connect the gas line from the spool gun to the brass barbed inlet in the wire feed compartment. Or, in some cases, directly to the flow meter. For aluminum welding, 100% argon shielding gas is recommended. The use of 75-25 or CO2 gas is not acceptable, as this will produce inferior weld results. Connect the weld cable from the spool gun to the positive stud in the weld compartment. On some machines, both the spool gun and the MIG gun will be hooked up at the same time. Although wire is only fed from the gun whose trigger is pulled, both guns will be electrically hot. Smaller Millermatics can be used to weld aluminum, but require the addition of a spool gun adapter, the SGA 100. The spool gun trigger and gas line will connect to this piece of equipment. A second gas line connects from the adapter to the flow meter. A trigger connector from the adapter connects to the front panel trigger receptacle on the Millermatic, and a weld cable connector goes to the positive stud. You may need to replace the ring lug with a small lug adapter to make this connection. Once these connections are complete, plug the adapter into a standard 115-volt outlet. Be sure to release the drive roll tension arm while using the spool gun, so that the wire will not feed out of the MIG gun when the spool gun is triggered. Millermatics requiring a spool gun adapter will not include aluminum parameters on the internal chart. These will be provided with the SGA 100. The control on the front of the adapter is used to set the wire feed speed for the spool gun. To install the wire into the spool gun, take off the nozzle and contact tip. Be sure that the monocoil head tube liner does not fall out. If it does, reinstall it prior to installing the wire. Next, remove the spool canister cover. Unwind 6 to 8 inches of wire, clip off the end, and straighten it. Feed the wire into the inlet guide. Press the trigger until it feeds out the end. Replace the canister cover and reinstall the contact tip and nozzle. Drive roll tension on spool guns should be set low to minimize the distortion of the aluminum wire. For correct drive roll tension on the 30-35 and 35-45 spool guns, the tension screw should be turned fully clockwise. If you're using either the 30A or 15A Spoolmatic gun, begin by loosening the thumb screw on the canister cover and remove the cover. Next, unwind 6 inches of wire. Clip off the bent end and straighten the wire. Now, lift the arm and open the pressure roll assembly. Thread the wire through the canister inlet guide, along the drive roll groove, and out the contact tip. Be sure to install the wire so it feeds from the bottom. Use the drive roll tension thumb nut to increase or decrease drive roll tension based on wire diameter to eliminate wire slippage between the drive rolls. Close and secure the pressure roll assembly and reinstall the top cover and canister cover. Reinstall the contact tip and nozzle. If possible, recess the contact tip approximately 1/8 inch inside the nozzle. Here are some tips to ensure good results when welding aluminum. Only aluminum materials of 14 gauge or thicker can be welded using the MIG process, as the heat required for this will burn through thinner pieces. For thinner materials, the pulse MIG process may be required. To remove oxides from the surface of the metal surface, use a stainless steel wire brush that is used for this purpose only. Wire selection is important for good results. Contact your local distributor for assistance selecting the correct aluminum wires for your welding needs. Use a 10 to 15 degree push travel angle when welding aluminum, as this cleans the weld bead. If a drag angle is used, the weld bead will appear black and sooty. Hold your tip approximately 3/4 of an inch from the work surface to prevent burnback and other feeding problems. Set your starting voltage as recommended on the parameter chart, and fine-tune as needed. The voltage should be high enough to produce a spray arc transfer, which will sound more like hissing and reduce the amount of smoke and spatter produced. When welding aluminum, your travel speed will typically be faster than with steel wires, and you will need to speed up as the base metal heats up. Avoid large weave beads on aluminum. A straight weld or short stitch motion is preferred. The troubleshooting section of this program contains more information that applies to MIG welding with all metals, including aluminum. Effectively using the MIG welding process on aluminum requires a higher level of skill that develops with practice. Use of proper materials and correct machine settings are critical to successful welds. The flux core arc welding process and self-shielding wires can be used when welding outside or where other environmental conditions prevent the use of an external shielding gas. In this process, the outer covering and flux core melt in the heat of the arc, producing shielding gas and creating a slag covering that protects the weld pool. This process also creates more smoke and spatter than other types of MIG welding. A few changes need to be made before beginning. Polarity of the weld circuit needs to be switched to electrode negative. And since no shielding gas is required, you should shut off the gas supply. You may opt to remove the nozzle as well. When you're finished welding, you'll need to chip or brush the slag from the weld bead. Make sure you wear safety glasses during this procedure. Welding requires the proper combination of materials and machine settings as well as practice. But here are a few common problems to watch out for. Bird nesting, a common problem with softer wires, occurs when the wire becomes obstructed and cannot feed properly through the gun. When this happens, wire collects around the drive rolls, creating a bird nest. Replace your contact tip if it's the wrong size or in poor condition. A strong bend in the wire can cause this also. You may want to decrease the tension on the drive roll as well, so a restriction will cause them to slip. Remove the bird nest by flipping up the drive roll and pulling the wire back out of the gun. Trim off the affected wire and rethread. Burnback can occur if the wire feed speed is set too slow or if the gun is held too close to the work, and will cause a weld to form in the contact tip. If this occurs, you will need to change the tip. Remove the nozzle, unscrew the tip, which may be melted to the wire, snip the wire off, replace the tip and tighten, and replace the nozzle so that it's flush with the end of the contact tip. Shielding gas protects the molten weld pool from contaminants in the air. Poor gas coverage or an incorrect flow rate can cause deficiencies in the finished weld, such as porosity, which is pinholes in the weld. Make sure all your gas connections are correct and secure. Check the flow gauge to be sure that the cylinder has sufficient gas, and check the gas flow rate. All Millermatics are equipped with thermal overload protection, so that if the duty cycle is exceeded, the weld circuit is de-energized to prevent damage to the power source. The duty cycle of each machine determines how long it can be run in a 10-minute period at its rated output before it must be allowed to cool, and it varies from model to model. For example, a machine with a 60% duty cycle at 160 amps can be run at 160 amps for 6 minutes and then must be allowed to rest with the fan running for 4 minutes. If the thermal overload circuit is engaged, you will not be able to weld until the machine has cooled enough for the circuit to reset itself. On smaller Millermatics, a thermal overload light on the front panel will illuminate if the duty cycle is exceeded. It is not necessary to shut off the power to reset the thermal overload circuit. Continually subjecting your power source to thermal overload may cause permanent damage. You are now ready to put your Millermatic to work, performing a wide variety of metal fabrication and repairs. If you encounter problems with your welding results, your local distributor is a great source of assistance. Additional educational materials available from your distributor and from Miller Electric can help you further increase your welding knowledge and proficiency. With a bit of practice, you'll be producing great weld results. Happy welding!